Good evening, students. Last class we have studied electric field due to a point charge, then electric dipole. Again, for the first 1 minute we will make a revision. First of all, the electric field due to a point charge. Suppose there is a charge q which is called the source charge. What will be the electric field at a point A which is at a distance r? The formula is 1 by 4 pi epsilon naught q by r square. And what is the definition of electric field? It is the force experienced by unit positive charge at a point, that is E is equal to F by q naught. You refer your classwork. Now electric dipole. Electric dipole means there are two equal and opposite charge like plus q and minus q separated by distance 2l, then this is called an electric dipole. The example is any salt which we have studied in chemistry, like HCl, H plus Cl minus, NaCl, Na plus Cl minus. These are examples of electric dipole. Here I have shown you the axial line and equatorial line. If a line passes through both the charge like plus q and minus q, if the line passes through both the charge, this is called axial line. And if the line passes through the center of the dipole and perpendicular to the dipole, then it is called equatorial line. And yesterday we have seen the electric field due to axial line. And dipole moment means it is the product of either charge, either you can take plus q or minus q, and the distance between them, that is 2l. Before going to the equatorial line, I will show you one numerical of electric field which you get in your homework. There are two charge 2 microcoulomb and 16 microcoulomb separated by distance 1 meter. Find out a point between them where the electric field is 0. So this is one charge 2 microcoulomb, this is another charge 16 microcoulomb separated by distance 1 meter. You have to find out a point between them where the electric field is 0. Suppose O is the point where the electric field is 0. And O point is supposed at a distance x from 2 microcoulomb. So what will be this distance? The total distance is 1 meter, so this will be 1 minus x. Now what is the electric field at the point O due to the charge at A and due to the charge at B? Here if you put a unit positive charge plus q naught, this charge will repel and this charge will also repel, means the electric field is in opposite direction. So if their magnitude are equal, then the net electric field will be 0. So EA is equal to EB. If both the magnitude are equal, then the electric field will be 0. So what is EA at the point O? 1 by 4 pi epsilon naught 2 into 10 to the power minus 6 by x square. EB will be 1 by 4 pi epsilon naught 16 into 10 to the minus 6 by 1 minus x square. This 10 to the power minus 6 is due to microcoulomb. Now all will cancel out. 1 by x square is equal to this. Take the square root on both the side, 1 by x. By solving this, you will get x is equal to 1 by 2 root 2 plus 1 meter. This is the answer. Now today we will see the electric field due to equatorial line. Before that, what are the electric field due to axial line? Yesterday we have seen this electric field will be equal to 1 by 4 pi epsilon naught 2p by r cube. This is the actual formula for an ideal dipole. Ideal dipole means if the length between both the charges are very close to one another, or we can take L is equal to 0. Then this will be r square to the power, this L is 0, r square to the power square r4. So this will be r cube. 1 by 4 pi epsilon naught 2p by r cube. Or electric field is proportional to 1 by r cube. And for a source point charge, how electric field varies with distance, this is 1 by r square. For a dipole, this is 1 by r cube. Remember this comes as one more question in your board examination. Now come to electric field at a point due to equatorial line. So this is your electric dipole. This is plus q minus q separated by distance 2l. This is the center O. This is your equatorial line. This is the point P where you have to find out the electric field due to the dipole. So what is the electric field at point? This distance is suppose r. This is L and L. So what will be this distance? This is Pythagoras theorem, root over L square plus r square. This is also root over L square plus r square. What is the electric field at P due to the charge at A? 1 by 4 pi epsilon naught q by root over L square plus r square square. Square means this will be L square plus r square. Similarly, electric field at P due to charge at B, again it will be q by 1 by 4 pi epsilon naught q by L square plus r square. Now what is the direction of EA vector? This positive charge will repel the unit positive charge. This is the direction of EA vector. And what is the direction of EB vector? This is negative charge. So this is the direction of EB vector. So this is EA vector and this is EB vector. This is the angle between them. So how to add them? We will use the resolution of vector technique. So here if this angle is theta, this is also theta, because this is theta, this is theta, these are equal, so this angle will be equal, these two angle are alternate angle, this is corresponding angle, so all will be theta. Resolute EA, this will be EA cos theta, this will be EA sin theta. Similarly EB, this is theta, this is EB cos theta, this is EB sin theta. Now the magnitude of EA and EB are equal, so EA sin theta and EB sin theta both are equal and opposite, so they will cancel out. So what is the net electric field at the point A? It will be EA cos theta plus EB cos theta. Again, as the magnitude of EA and EB are equal, so this can be written twice EA cos theta. So this is EA plus EB cos theta, that is twice EA cos theta. Write down the value of EA, 1 by 4 pi epsilon naught Q by L square plus R square. So what is cos theta here in this triangle? Cos theta will be B by H, L by root over L square plus R square. So L by root over L square plus R square means to the power half. So this will be total 1 by 4 pi epsilon naught P by L square plus R square to the power 3 by 2. In the numerator 2QL, this will be P. So again for ideal dipole L is equal to 0, so this will be 1 by 4 by epsilon naught P by RQ. So for XL line it was 2P by RQ, for equatorial line this is P by RQ. So this electric field due to dipole on XL line is twice the electric field on equatorial line. This comes as one more question in your board examination. It means suppose there is a dipole, if the electric field at a point on the axial line at a distance 10 centimeter is 5 Newton per coulomb, what will be the electric field at a point at a distance the same 10 centimeter on equatorial line. So by using this formula you can find out the electric field on axial line is double that of equatorial line. For today this is the electric field due to electric dipole, and remember this, for point charge electric field is inversely proportional to R square, and for dipole electric field is proportional to RQ. There is one graphical question. This is the question. The graph represents the variation of electric field due to with distance for a point charge, for dipole and for linear charge. Till date we have not studied linear charge. Identify the graph. So here A will be point charge, B will be dipole. Sorry, A will be linear charge, B will be point charge, C will be dipole, because for linear charge E is inversely proportional to R, for point charge E is inversely proportional to R square, and for dipole E is proportional to 1 by R cube. So this is linear charge, this is point charge, and this is dipole. This linear charge we will study in the next class. So thank you.